Oh, we're live. Hi, Mike. Welcome to Winter with Grace.
Hi, Grace. How you doing?
I'm surviving. I'm good. How are you?
Good. Is it the surviving the flu season, or you managed to escape that?
I don't think this is flu because I've been like this for the past week, and then everybody around me is totally fine. So hopefully this is not contagious, which I don't think it is. But yeah, no idea. What about you? Are you in flu season right
It's
now?
good. Managed to escape this all. A lot of travel at the beginning of the year, but it's settling down now. So it's time to hit the ground running for the year. So it's good time.
For sure. Okay, so let's start with I feel like you come from a very deep research background, and then you were, I mean, you're currently still is the professor at Princeton for computer science, and then you're a CTO of Timescale, and then you started businesses. Like, this is not your first company. You have started previous companies, and then it got acquired. Maybe we could briefly talk about what were some core lessons that you've learned early on in your career that you kind of use later on, especially coming from a research to founder background.
A lot of questions there. Maybe I could add two things, both kind of what motivates me and what's interesting about balancing between academia and startup world,
Mhm.
and two, kind of some of the surprising things have found in startup world. And I did have a startup before. It was a quickly acquired one where Timescale is really the first journey where we've really scaled it to a much larger thing
Mhm.
before. I think the first thing is what always motivated me as a developer, as a researcher, as a computer scientist was I worked on problems that I worked on things that solve people's problem. So
Mhm.
actually, the funny thing is, if you go back, showing my age a little bit, but if you go back 25 years, I initially started by working on a lot of privacy. So I
Mhm.
was doing a lot of computer privacy, was doing eCash and crypto before
Mhm.
crypto was a thing. And what was interesting there, I found out, is that you spend a lot of time trying to add privacy or security to protocols, but often that comes at the cost of usability, you
Mhm.
know? And what I ultimately got, I kind of moved to become more work on core systems, because in the end, there's this product problem. And I never knew until now it was really a product problem that people have. So I
Mhm.
did a lot of work in peer-to-peer systems, on content delivery networks.
Mhm.
And you're kind of thinking how do we build systems that solve that core need of people? And I think you could do that in research.
Mhm.
But I think you could also sometimes, if you want to actually deliver a product to people, I
Mhm.
think the great thing about startups and entrepreneurship is you could build it for real, get real customers, get real
Mhm.
users, and kind of go through that whole journey experiencing it with your user.
Mm. Um, okay, so core need of people and then get real users. Love that. Okay, so I have a question about timescale. Okay, maybe we'll just start there because okay, obviously I've listened to your other podcasts I've mentioned before, we came on, and I wonder, okay, can you explain what is for Postgres for normies? And then what does time series means for normies?
Sure. Uh, so Postgres is one of the probably the most popular open source
Mhm.
databases.
Mhm.
If you think of any service that you use, your
Mhm.
bank, your website, your email,
Mhm.
in many cases, the thing behind that is a database.
Mhm.
So you're interacting with a service. There's a bunch of compute. It's running some stuff, but ultimately, that
Mhm.
data behind the scenes, behind it, is being
Mhm.
stored as a database.
Mhm.
And you could think of that as a
Mhm.
very reliable way to store data. And the canonical example you always teach on is a bank where
Mhm.
you want to store your bank balance, you want to have updates, you could update it, you could remove data, and it kind of keeps it in a safe and consistent or transactional fashion.
Mhm.
So now fast forward and so people have been building apps on top of databases
Mhm.
for decades. In fact, Postgres had its root in the early 90s. Even though it's
Mhm.
one of the most popular software databases today, it was really started, more than 30 years ago.
Mhm.
A lot of people's use of databases, if you're building a web app,
Mhm.
uh, they call this a CRUD database. CRUD for create, retrieve, update, delete. That is,
Mhm.
you're adding data, you're removing data from your database. You don't have that much data. It's relatively slow. Everything's easy.
Mm.
And now people want to deal with a lot of applications that are data heavy. You're constantly ingesting data. You often want to query things. You don't want to, let's say, retrieve one observation or one record. You want to know about a lot of stuff, about how data changes over time. And this is from many different scenarios. It's one use case we see a lot is sensor data. You have either your Nest thermostat, or it's a sensor running at deep in a mine that's collecting a lot of data about how things change over time. You want to collect not just the stream from one sensor, but the stream from 100,000 sensors. You need a place that can scale to store with it. It's also game data. So you're playing a big, online game, and you just frag somebody, you shot them. That's an event in the game. There's millions of these events happening continuously. You need a place to store and analyze this data. That's where Timescale steps in, and we serve everywhere from industrial companies to digitally native companies to music and social media and gaming and crypto companies. These are all they're all trying to build real-time analytics on top of their data.
I'm just literally furiously typing just so I can keep up. Okay. So, okay. Create, rewrite, update, and delete. Like, which part does, like, I guess, Timescale will play into it? Assuming everything, or like, I know that you also mentioned this is like an open source project. Like, how does it work?
Maybe I could, rather than talk about, I'm happy to go into how, but maybe it can get a little technical there. What I will say is that Postgres itself and most database itself were not designed to deal with the volume, kind of the speed of the amount of data coming in at you versus the types of, where you want to actually query lots of data over time. Let me give you a different example, which might draw this. If you are building now this is obviously at a very high scale, but if you think about a social media company like Facebook or Twitter, you might create a record, create an entry in a user table every time somebody signs up, right? And so you can imagine, yes, Facebook itself has billions of users, but it has billions over the course of years. The actual frequency of adding a new user is relatively infrequently. But let's consider their ad system, which is trying to record an event every time you view a page. That is operating at thousands or millions of times higher velocity than adding a new user. So you can imagine that the type of infrastructure you want to be able to keep up with this high velocity data and being able to in real time query it just requires different type of software, different algorithms, different data structures, different way to store it, lots of optimizations, and so forth. And so that's what we've built with. We've managed to take this traditional database that is the most beloved database kind of around the world by developers, and then do a lot of advanced technologies changes inside of it, still run on top of the same open source database, but now make it work unlock these new use cases for these data heavy industries.
So I saw that your customers, I mean, you mentioned about this on another podcast about you guys have crypto users, you guys have a lot of deep, you guys work with the deep tech users, basically I guess whoever use data the most, and then obviously on your website there's a lot of big brands, right? So I guess and then okay, this may be very, very dumb as a question, but obviously on the pricing side, there's only, I guess $30 a month for storage price at X amount of GB per month. How is this going to be a $1 billion business if you're selling $30 per month stuff, unless you are, I guess everyone use it all the time?
Sure. So I'm happy to talk about pricing. So Timescale, and for this I'm talking about our managed cloud, which is where the majority of our business is. We're inherently a consumption-based business. And so we have kind of several different tiers of service, which talks about different feature functions available at different tiers. But in each of these tiers, people use our service, and they're basically, it's compute and storage is separate. And we have a price per hour for compute and a price per gigabyte per hour for storage. And then, yes, we advertise starting out $30. It's because that is the smallest instance that we could run. But absolutely, we have people storing, hundreds of terabytes with us of uncompressed data, and they're definitely not spending $30 a month. So, I think we've built, we serve everywhere from, like you said, some of the largest companies around the world to, 3-person startups who are being very innovative and yet operating in a kind of with a lot of data themselves as they start.
I wonder, so okay, so what is in the modern AI stack for like a tech company?
Sorry, you said what is in the moment AI stack?
Like a modern AI stack. So the modern AI stack, because currently I'm just seeing because on your website it's like you guys are working with a lot of companies. So there's OpenAI, there's Vercel, there's a bunch of stuff, right? So how does Timescale plays into the backend to help them, I guess, storage and then processing data? And what does the normie process look like, and then versus using your service?
Yeah. So I think, one I'll say is, I'm very bullish on AI in general and how it's going to change a lot of the ways we build products. In fact, I imagine 10 years from now, people aren't going to you don't talk about mobile companies anymore, or you don't refer to companies as .com companies as you did, 10 or 20 years ago. You just call them companies. And much like I don't think we're going to say this is an AI app, we're going to call it an app, and most apps will have AI. I think what we see is much like, there's different ways we build software. There's, different applications will embed AI in different ways. And so, kind of the basis of the question, like the modern AI stack, is that I think that different types of applications with different needs are going to use AI in a different way. For example, people sometimes refer to it as the modern data stack. You've probably heard that phrase. A lot of the users who are calling the modern data stack are coming from the data warehouse and the data lake world.
Right.
So a lot of data lake worlds are meant to serve internal business problems. They're either business analysts, they're internal dashboards like business intelligence, BI dashboards. Sometimes the data lake is there to serve machine learning training, where, most applications are still, built with microservices and databases. So the modern data stack isn't often referred to them. So I think that, similarly in AI, the last 10 years, we were in an era where people were trying to train models. That's where companies like Databricks had their start. Now with the rise of Gen AI, we've moved from that training phase, what they call inference, which is really let's serve customers, and our models are in production, let's serve customers. And there's going to be AI applied to internal business problems. And there's going to be an AI that's embedded in websites and applications that people use today. Bringing this back to Timescale, we are serving developers building customer-facing applications. And so from that, where does AI play a role? Today, I think we see that it's in a couple different parts. We see this in it's sometimes called RAG, is the technical frame, but it's really about how do I customize these general models? OpenAI and Anthropic and Google has built this model against the totality of the internet of what they've been able to search. You have your own, if you're in, you have your own documents. You might have your own internal knowledge base, and you want to be able to build a chatbot on that internal knowledge base. So basically, what you do is you take your internal knowledge base and you encode it, and you create what they call a vector encoding that kind of distills the information in that own knowledge base. That information is often stored in a database. It's stored in a vector database. And then so when you have a chatbot, what the chatbot first does is it looks up in your database, tells me something specific about this company, gets that information. This is what's in my knowledge bases, and then passes it on to the foundational OpenAI model to be able to like generate an answer to it. So again, I don't think there's emerging AI stacks. There are different stacks, one for, let's say, training, one for chatbots and answering RAG kind of questions, one for agents. And so you're going to see the constant evolution.
Okay, so I want to maybe go back a little bit on like, what were the things that you were researching and then how is it related to your current company?
Yeah, so my research has always been in the area of distributed systems. And so in general with distributed systems, you're like, how do you get a bunch of computers to work together to solve problems at scale where you care about performance, you care about failures always happen, stuff happens. How do you build a highly available system when stuff's happening? And so over the years, I've, gone between, like I said, how do you get a bunch of things around the internet with peer-to-peer systems? How do you build content delivery networks? How do you build robust storage architectures? How do you take different changes in the underlying hardware? We have these new generations of hardware that emerge. How do you combine all these different hardware together and, build robust systems on top of that? I think that, Timescale didn't start because we were like, hey, we had a research at Princeton and trying to commercialize that. Frankly, I actually think that's not the right way to, I could come back to this. I actually think the goals of research and the goal of startups and products are pretty different. But I think that, the training one gets of trying to, build highly performant, high scalable, highly available systems absolutely translates to, not just building a database, but now when you're building a managed cloud, how do you provide that service for tens of thousands or hundreds of thousands of distinct databases?
I want to go back a little bit on like, since you guys have successfully raised from like literally all the tier 1 funds, and then you have landed like a bunch of different logos, like maybe talk to me about like, 7 years ago, like how do you actually turn from like the research into a product, and then from the product to a company? Maybe it just turned into a company, and then like, I guess like the iteration. What does that kind of look like for you?
So first of all, it has been we launched Timescale in 2017, so it was about 7 years ago. Even though we were kind of kicking ideas around before that. My co-founder is actually an old friend that goes back more than 25 years. So this is a long-term friend we met many years ago, and it was a good time for both of us to try to think of kind of new challenges in our career. There's different people. We've had great investors, as you mentioned. Kind of our seed round was with NEA, our Series A with Benchmark, Icon, and then Redpoint led our B, and Tiger Global our C. And obviously, what you need to do to demonstrate at seed round and Series C look very different. NEA took a bet with us, mostly in the beginning, with what our vision was for building infrastructure for this next generation of sensor devices, and partially because of our, let's say, our technical and professional background, more than we had kind of early adoption by customers. Obviously, as you move on, it turned into like we were open source. We launched that. By the time we launched our Series A, you actually see signal from the open source adoption. And, open source is a really interesting way. And I think we're seeing that with AI now. It's a great way to feel the pull, at least the product market fit, before you actually feel the pull of the commercial side of the market, like how you monetize that. The good thing, I think, at our time, the understanding of how you monetize open source was pretty well established. It's gone. We've written a lot about this, about the different phases of open source companies, but it's pretty clear in the last 5 or 10 years, it's moved towards selling open source as a service, where you actually run a managed service, and then it changes your relationship with your customers, which I think is really interesting. You're no longer selling them software. You're selling them a product experience, and you own availability and performance, as opposed to you're not just shipping them bits and hoping it works.
I wonder, so like, in your mind, in the last like 7 years, like how do you separate, like let's say like each 2 years as like a new milestone for yourself, like to grow your company as a CTO?
So I think there were really probably 3 phases of our company, if I had to think. Phase 1, when we were initially building just our our database, which we call Timescale DB. And that was initially open source. It was about, are we building things that people care about? Is it solving a problem for them? We were focused more on building the community, building adoption, seeing if it's sticky. Are you delivering value? Not yet about our business. That we launched in 2017. I would say that was the first 2 or 3 years. We made the decision pretty early to really say, hey, if we want to build a business, we think that the best way to build a business for this open source is to provide a managed service. And so we made the decision our main go-to-market is going to be focusing on delivering cloud and what some people call PLG, product-led growth, a really seamless thing. And that affects a lot of your go-to-market too, as opposed to building a big top-down enterprise sales. And we one interesting thing as a founder is the engineering team that is going to build an internal database that ships software quarterly, writes low-level C code, is not the same type of engineering team that's going to build a really effortless cloud with a great product-led growth experience and great developer experience. So we actually built almost it kind of changed a little bit of the culture of the company, and we built a whole we hired a completely new set of folks to build our cloud. We started building that in 2019, kind of launched it in 2020, more in GA. And, I think then the biggest phase of the last 5 years has been when you move from an early stage company to one focusing on, growth. And in the end, as it means for many companies, what is the commercial reality of how your company is growing? And that obviously means you're just competing in a bigger and bigger market against, better customers, or better competitors, and becoming a more critical part of our own customers' stack.
What does it look like in terms of like selecting the first potential customer, or like the first like type of ICP? And then you mentioned about like product-led growth, like how, I guess, like how do you transform yourself from like a scientist to like a product guy? Because I feel like that requires like very different skill sets.
Yeah, I think 2 things. I heard 2 questions there. Let me start with the first one, which was, how do you pick those first customers? When you're just starting out, you're just figuring out what is resonating. There's been a lot written about this, crossing the chasm, the lean startup, like how you think about finding your ICP. In the beginning, you don't know, right? Over time, you start seeing, where is it resolving? Where do you feel that pull, combined with what do you see as the future of the market? And I think, one thing I guess I've learned as an entrepreneur is that as important in knowing what to do is knowing what not to do. You have to be willing, you both have to be willing to say no and have conviction about your no's, as well as being willing to like know when information changes and pivoting to address that. So for example, you feel in the beginning a lot of pull from different places and you don't know what there is. And sometimes it's hard to say no. And we had conviction pretty clearly that we thought the future of people buying data infrastructure is moving to the cloud, and that we would much rather start bottoms up through PLG, growing into sales led, then top down. That is, I think it
Mm-hmm.
is easier to build a product in a business where you start bottoms up and
Mm-hmm.
then grow up into enterprise, then start with the enterprise and then trying to get PLG after that.
Mm-hmm.
And so that meant saying no. I mean, maybe the best example I like to say was, this was a number of years ago, when one of the largest stock markets around the world came to us and says, we want to deploy you in our private data centers. Come work with us for 3 months to deploy us in your private data centers. Now, we said no to that. And that's hard for a lot of founders to do. But I think if you constantly allow yourself to go in every direction, you're ultimately not going to be able to build your business.
Mm-hmm.
Into that repeated ICP that you talked about.
For sure. I guess like, why did you say no to the?
Correct. So we thought that we wanted to build a cloud-centric PLG bottoms-up motion. And this is an on-premise, top-down enterprise. So.
Oh, okay. That's really interesting, but I would think I would just take whatever and then to build up the credibility. Even you are selling bottoms up, like, you know, it doesn't hurt when they see, oh, blah 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 is using this thing.
Yeah, so we did in the first 2 years when you're just building. I mean, the first 2 years we were, building our open source software. You put it on GitHub, people start talking to you, and naturally some of those conversations turn to commercialization. So you're always starting by that. And in the beginning, we did have a small number of like enterprise on-premise deals. And I remember talking to other founders, and they're all like, you're not going to be able to do both. You got to pick one. And we're like, no, we're going to show you how we can do both. And after some amount of time doing this, we realized that we couldn't do both. And the reason you can't do both is ultimately both your product and your go-to-market look very different. I mean, if you take one extreme, the persona of your salesperson, their comp structure, how you define quota, the timelines at which you close deals, those are going to look very different if you're selling on-premise enterprise than if you're doing PLG. And again, the challenge is it's better to get really good selling at a certain ICP and expand as opposed to just trying to do a little all over the place. That's not how you kind of become repeatable and scale, I think, unless you figure out exactly who you're selling to, build a product for them, and add more and more value, and find out how from there you could expand to new segments.
I wonder, okay, so since like right now, I feel like, I guess like, how do you structure your day being the professor as well as like doing all the CTO work? And this is like your organization, according to LinkedIn, it's like 176 people. Like maybe I guess like let's say half of them are engineers. Like how do you like structure your team? And how do you balance like the product development and like actually thinking about the future trends, building something long term? Oh, we had a CTO on last week, and he was talking about building long term and short term because there's a lot of feature that you could be building today to satisfy the client's need, but like in the end of the day, you have to think about things long term as well. So how do you think about these things?
Yeah, I mean, first of all, I probably don't sleep as much as I should. I still manage to teach full time, have some research going on, and obviously contribute to Timescale.
Can I also ask, how do people research? Like, and then especially as a professor, is that like, okay, you manage like 5 PhD, be like, hey, you do X and then you do Y and then you do Z, or like?
I mean, two things. I actually try to keep my research in Princeton pretty expressly separate from any work I do at Timescale. So I don't try to mix it all, just because it's not good to intermingle these things. I will say, I mean, I'm happy to talk about my philosophy of research. What's interesting is that I think the goals in research and the goals in companies are actually quite different. In a company, I think you're all pulling in the same direction. You have a singular goal as a company. You're all trying to achieve it. In research, I mean, yes, you're trying to do research, but part of your job as a professor is also to train the next generation of PhDs and make them successful.
Mhm.
And my philosophy with that has always been like, the best PhDs lead their own work. They're not just
Mhm.
like one person in 10 working on one topic. And
Mhm.
so in research, I would do more things where like lots of small projects,
Mhm.
individual projects led by a grad student, as opposed to one big project in my lab with lots of grad students working on it. Some faculty I know differently. That has always been my philosophy. I
Mhm.
think the interesting thing about that has been the interesting thing about being in startup is you actually
Mhm.
get more people going in the same direction,
Mhm.
um, which is also a nice change. You asked me a second question there too about how I think about building for the future and present, and yeah, I mean what your last guest talked about, or what your recent guest talked about, is definitely how we think about it too. Generally, kind of divide the amount of, I mean, this also matters more as you start to
Mhm.
scale, divide your investments into, the percentage you're doing with, short, medium, and long term,
Mhm.
what things are growing to expand your, solve the immediate needs of your current customers,
Mhm.
bring their next value. What are larger bets you're doing? One of the biggest things about a year and a half ago, in general, we make Postgres work for demanding applications. And so that started by taking Postgres from a traditional CRUD database to real-time analytics.
Mhm.
And now we're really supercharging it for AI. So one of
Mhm.
our, for example, big investments over the last 18 months has been, how do we make Postgres now a very powerful database for AI? That's one of those long-term bets that we'll say this fraction of product engineering might focus on it, while a lot
Mhm.
serves our existing time series business.
Mm. Like, what does it mean to make it more AI? Like, what are the features that you'll be building? I mean, obviously, don't say anything you can't say, but like, I guess,
Sure.
like, what's the direction that you're going?
Sure. Well, I mean, two things. I gave some examples before
Mhm.
with these type of use cases, and one of the common mechanisms that a lot
Mhm.
of these Gen AI applications need from a database is
Mhm.
is is what I described, is be able to efficiently look up these vectors.
Mhm.
So most of things like ChatGPT are encoding large amounts of data in this vector representation, this high dimensional representation, and it's basically a search problem. You're basically
Mhm.
saying, "Hey, I asked you a question." Like if you think about traditional keyword search, you might say, "Look up all bananas,"
Mhm.
and it would do an exact word on it, match bananas, but it
Mhm.
doesn't match plantain, right?
Yeah.
With this kind of Gen AI, it has actually a different representation of it. So it
Mm.
kind of understands some of the clustering of semantically. So now I have this search space where a human could ask for bananas and actually return a bunch of records about plantains and other contexts. And
Mhm.
that is what I pipe into the OpenAI model to answer.
Mm.
So a database, much like a database becomes a building block for building things like agents and chatbots, much like a building block is a storage, much like a database is a building block for your web app.
Mm. Um, I wonder, since, like, we're, talking about, like, data and AI at the very beginning, so, like, what do you see as some trends? Like, where does database where will database be moving, basically?
Yeah, so I see very much along the lines of what we were doing. What was, in my perspective, what was interesting is databases have traditionally served that operational use case.
Mhm.
I want to power your banking app, your web app, whatever.
Mhm.
What Timescale came about, again, serving that, your live dashboards that you see, that's
Mhm.
powered by also a database. And now with AI, we moved, the first wave of AI, which we heard for the last 10 years, was about, I have all this data. How do I build a model? That's
Mhm.
training.
Mm.
And now people are actually, we want to make every app that we interact with often be powered by AI. And so we often will, I gave some examples of use databases to serve
Mhm.
those customer facing applications. Um, the foundational model is useful,
Mhm.
but the foundational model has been trained basically once.
Mm-hmm.
And there is work on people are talking about fine training, like fine tuning a foundational model.
Yeah.
But this still generally happens on like relatively long timelines and requires a certain level of expertise. You're not, you might have a different data set for users. So for example, if Google with Gemini wants to allow you to have a chat bot on your own Google Docs, they're not going to fine tune a different model for every of their billion users. They're going to basically use the type of vector indexes we do in a database to be able to allow you to search on your own data before you actually are able to answer a question through that LLM.
Talking about like apps powered by AI. So right now, are they not powered by AI?
I'm not sure I
don't. I'm sorry. Like, okay, so I'm just trying to understand like the
okay, maybe I can answer it this way. So like the first generation of AI powered app was, we had a lot of data, we trained a model, and then we deployed that model. And that model basically answered, it kind of answered everybody the same. Now, I mean, the way it answered was dependent upon what you'd ask it, but it kind of was answering everybody the same.
Yeah, so it's more like personalization. So
yeah,
like,
and so I mean, it still would like Netflix recommendation service is still personalized, but the model itself is kind of like encodes all the personals. It trained, Netflix took its like years worth of data, trained a model, deployed into production, and it answered everybody exactly the same thing. And there's actually this problem of like keeping it up to date. So like every month you need to train it. And in fact, people would keep track of model drift. That is, well, the last time I trained it was like a month ago, and now something is trending. Is that reflected in the new model? I need to like roll out it, retrain it, roll out all those things. And I think where we start seeing the use of databases is that it almost is like a cache of information that the model is speaking to, or that you pump into the model to give it extra context to answer kind of what's in the now, or how should I answer this question with, for Grace versus how I should answer it for Mike. And that is the type of thing that, didn't really exist before.
So right now it's like real-time training. Is that what you're saying? So like basically I input some information, and then like whenever ChatGPT or like whatever answers my question, it just like immediately like digest every context of like whatever I have put in, and then come up with something.
Yeah, it's doing real-time answers. I mean, maybe if I'm being pedantic, I wouldn't call it training. Training generally suggests you're changing the model, but more like you're able to use that real-time information. The model is able to use that real-time information and real-time context to answer it differently.
Oh, wow. Interesting. So like
a different take on this is, you might have recently seen large context windows. I don't know if you've heard about, some of the new models have very large context windows. Some of the new OpenAI models, Gemini models, DeepSeek. What that context window is how much information can you pass into the model? So if they want to know about Grace, like Grace asks one question. Do I pass in, when I ask that question, every possible thing Grace ever did in the last 20 years? That would obviously be a lot of data. So this context, and it would be very expensive to process 10 years of data to answer one question. So while people are building larger context windows, there's this inherent trade-off between like, do I need to process all this new data to answer that one question? Or do I have this like efficient lookup algorithm to keep on the side, keep track of Grace's history, but then when Grace asks a question, know exactly what about the history is relevant to pass on to the model to ask. And that's kind of the role of databases today. One approach is, I make my context window massive. That works. It's super expensive and doesn't scale. or do I build these like lookup algorithms that allows us to extract out what might just be useful and pass that on as well?
So from the database perspective, like is all my data just like storage in that thread and then like delete it when the thread was deleted? Or like, so for example, how do they answer these like these questions tailored to me? Like, do they have to process the data real time and then like or like do they storage my historical data for good? And so that means like a lot of database
Yeah. So
maintenance or
and I'm trying to think about how to answer maybe this slightly less technically, but what is actually happening when you ask a question. So let's say
Mhm,
you have a chat bot and you want to ask a question like you have all these internal notes that you've
mhm,
kept and you want to be able to chat with your notes because you're
mhm,
forgetful like I am. What we've done is we've taken every note. And by the way, this is a product that also Timescale's built. We call it Vectorizer. Imagine
mhm,
that you upload all of your documents, your notes to the cloud.
mhm,
And every time you upload a note, you compute an encoding on it. I
mm,
basically process it.
mm,
And as you add more notes, I update that automatically. As you delete notes, I update that automatically. So I have kind of a searchable representation of all of your notes.
mhm,
And so then you like send it a chat query. You talk to a chatbot, ask this question.
mhm,
Your question also kind of goes through an LLM and gets encoded. And
mm,
then you're kind of running a search. You're running a vector
mhm,
search on the encoding of all your notes. And
mhm,
what that tells you is, hey, you asked this question. Here is 10 bits of information including citations to those notes
mm,
that best match the question.
mhm.
I then take those 10 documents or 10 links, pass them to the LLM, and the LLM takes those 10 docs in your question and generates an answer.
Okay, got it. So it's kinda like an agent before the agent, so it's just instead of me uploading 10 PDF, they find the PDF automatically and then upload it onto ChatGPT.
Yeah, and what when people talk about agentic AI now,
Mm, mm,
a lot of or sometimes talk about reasoning AI.
mm,
What those often do is that here's an example where you want to search your notes. What happens if you have an AI where you want to say, figure out my best restaurant, then make a reservation? Well, the
mhm.
best restaurant for me is based on like your own history. And so that's a
Right.
two-part answer. You kind of want the AI to then recognize, I first want to figure out what's best for Grace, and I can do a lookup here. I get that
Mhm,
answer, and then I have another bit of AI that actually knows how to speak to OpenTable's API. So a lot of times when
mm,
people talk about agentic AI, it's really these one-step programs, which was the first generation. And now we
mhm,
want to build agents that know how to go from that one step to reasoning, how I could break into a problem into multiple steps and
mhm.
kind of use a different approach in each step to answer to solve that problem.
Mm. So basically beside you AI or I guess like data storage is
Yep.
gonna be more as well as like it's more, I guess like you have to categorize them in different ways. Like what are other changes that beside like, in the pre-AI era
Yeah.
to like now
So let me
from
talk
the
about
database?
another thing that we're doing with Timescale with AI, and I mentioned already, make it easier to do things like RAG
Mhm,
and with notes. And most of that you can think about is search over unstructured data. It's
mhm,
like random notes, it's images. We have people doing image search with this and so forth. The other thing is we actually have a lot
mhm,
of structured data, which is the database.
mhm,
And if you're a business user, you might think of, you probably have looked at all these dashboards
mhm,
that ask questions like, if you're in venture,
mhm,
what is my ARR per cohort of my users going back months? Which cohort is my fastest growing? Why? What's interesting is that is also structured data. Now you could write a
mhm,
SQL query and access the database. But my question is, how do you have AI? How do you ask questions of your database
mhm,
in with English as opposed to
mhm,
actually have to write SQL? And so I view that as much like searching on text as unstructured retrieval. That's a
mhm,
form of structured retrieval. So one of the projects that we actually have going right now is actually this translation layer, which you could write human texts automatically, given the schema and given the data in your database, figure out how to write SQL, generates a SQL call at your database, gets an answer, then could pass this back to the LLM to give you that answer in English. That allows you to then ask questions of your data via human and kind of get answers, without needing to write that SQL yourself.
So how do you I guess as a CTO of Timescale, what are 3 things that you do to capture the new AI-led database changes?
Yeah. Maybe I could answer this in a slightly different way. I mean, to now we've been talking, somewhat technical or what we're doing from a product perspective. Broadly speaking, I think kind of role is, especially if we're talking about AI, is threefold. One is, what do we see the future of products looking like, and how do we actually make sure that we serve developers. People adopt Timescale because they're developers. They want to build their own products. What are the ways that AI is going to change how they're building products, and how do we, as a data infrastructure builder, build capabilities that help them? So that's one. What do we think? Where do we see AI is going, and what is the role of databases in building AI applications, and what features we want to do that? The second I think about is, obviously, how do I internally, build the right empowered teams that, especially, again, going back to the thing about short-term versus long-term, I think for the bigger bets, I like to build teams that actually have technical and product leadership on those teams, and also feel empowered, especially in this area that's moving very quickly. And I think 2 years from now, the market's going to look very different than what it looks today. How does that team feel like they can move fast inside a larger organization and really feel the pull of our own customers? And the third is, how do we actually across the whole organization employ AI not to build products for our customers, but to solve our own problems? We're thinking about deploying this on our kind of sales and go-to-market. We think about how we could use AI internally. We run at scale support organizations that, deal with thousands of support cases a year. How do we actually use AI internally? How do we actually dog food our own tools to build the chatbots to help us answer customers' questions faster? How does our engineering team start using AI? I do not think it's going to replace software engineers in the short term. I think it's going to be a tool that helps developers be more productive. We obviously work very low level, so you see a lot of great apps writing, testing or building web apps. You don't see, I think, AI, building databases end to end anytime soon or ever. But I do think about those. How do we build sort of business? How do we support our people? How do we empower the teams? And how do we build products that help our own developers build AI-enabled products?
What's the differences between all these database? I don't know if you consider database as application, or are they because just out of curiosity, if there's any particular subcategory of different databases.
Yeah, so I think that I would break them into, really, there's two different dimensions. I referred to several times, I think of databases that are used by developers to build applications, often customer facing. And on the other hand, you will have traditionally data warehouses, data lake houses. Those are meant to be let's throw all of your data in an organization to some point, and we're going to have it for training, for analytics, to often ask those type of ad hoc questions. So those are often handled by very different teams. We are clearly we serve developers, not data engineers, building those applications. Then within that bucket, I really think of twofold. There's what I'd call general purpose databases, what I would put Postgres and therefore Timescale in, and very specialized databases. So some people have done in-memory key value stores, graph databases. Some time series databases are very specialized because they only could support time series. What Timescale does is we take Postgres, a very general purpose databases, then we add additional capabilities. You can do multiple things with this. I think the big advantage of that is it allows operational simplicity. You could have one database in your organization or multiple copies of that technology that all of your engineers can use. And what we find is that for 99% of the companies out there, that is a better approach than deploying 5 different specialized databases, which requires more training, more learning, more operational complexity, and so forth. So that's kind of how I divide the world, like database versus data warehouse, data lake, and then within database, general purpose or a specialized.
And if
I can, like one of the interesting things with AI is very recently, within the last couple of years, what a lot of VC funds funded were these highly specialized vector databases. We saw a bunch of companies that were formed that only serve this one use case. And I think what Timescale and what there's other extensions on existing general purpose databases said, hey, you could basically get as much performance by using Postgres or others with this special vector capabilities. And then you don't need to deploy a completely separate database types that works only for that use case. So I'm very bullish again on that 99% of the companies out there should be using these general purpose databases, but then made powerful by companies like Timescale.
I wonder, so I can totally, now I feel like it's a lot more clear on the value proposition. And I wonder, when it comes to attracting developers, how do you attract the best talent in general? And then are they supposed to come from the research background, or are they supposed to come from the people who have been coding for, I don't know, winning 5 hackathons and as both as a researcher for, as well as the CTO? How do you think about hiring the best talents for your own company?
Yeah. I think that I think of the makeup of teams more than the makeup of individuals. And what I mean by that is I actually think that we benefit from having people with lots of different backgrounds. It's useful to have people who are, have research backgrounds. And some of the earliest hires we had, not surprisingly, several early hires came from Princeton, were my former students. It's also useful to have people who were professional developers for 30 years. It's also very useful to have people who have operational maturity, platform background. We just don't build a database, but we actually manage a large fleet of databases on behalf of our customers. And so, then when putting together teams, the question is not, in fact, I think that type of diversity of background, experience, skill set, some people are more interested in the engineering details. Some think a lot more about the customer experience. I think actually blending all those things together are what makes the best teams.
How do you know what kind of special function that you need for each stage? And do you create a product roadmap first, and then you hire the special subject expertise people to be hey, you guys build this, and then group them into pods? Or do you pick the best talent, let's say from your Princeton PhD program? You're hey, you 3 come with me, or what's a general concept of building a good team, basically?
Yeah, so it changes over time. In the beginning, you just try to get the best people you can who will join you, right? As you scale, I think there's 2 different parts of it. One is, I mentioned this before, we were building a core database. The skill of people could write, this is low-level systems internals. We write in C. The database is implemented in C. You're not going to go from a full stack JavaScript developer then writing database internals in C, or vice versa. And so some of it is based on interest. And so when we started to build the cloud, we actually looked for people who were, building on cloud, wanted to build, Kubernetes and, wrote, we use Go for a lot of our, so we do lose, I mean, most people are, run different languages, but again, you kind of like a type of work. You like to be, you like to be very customer, user facing. You like to do systems internals, and rarely those type of personas don't go between. And so, yeah, sometimes you head about that based on what your product roadmap is. Sometimes, like, as you grow, you realize, like, hey, we need to expand in this area. We need to kind of backfill things that probably should have hired 3 to 6 months ago. But that's the normal. The other thing I would say is, like, we obviously look for kind of culturally people that are really excited about, we want people to be excited about building amazing stuff and getting stuff done. And obviously we work on deep tech, if you will, or like at least from a software perspective. But we don't hire people who are just in love with the technology. We want people who are excited about solving problems for users.
Do you categorize each team to be in charge of like one group of users? Like, let's say, 3 people in the crypto area, and then like there's like 3 people in the, I don't know, building XYZ for this group of customer, or how do you kind of like separate the group of work?
Yeah. We obviously have engineering teams that are responsible for very different parts of the product. And obviously what we want to make sure is that every part of the product, every part of software is owned by a certain team, has clear ownership, accountability, sense of responsibility for that product. There are certain things where that mapping holds. So for example, the performance of database queries is going to be owned by the part of the database team it is. The reliability of the platform is going to be owned by the platform team. We don't, I think you described almost a vertical separation of like IoT and crypto and whatever. I do think that we think of those separately, somewhat from a go-to-market perspective. The product marketing you might do for these different, and some of the features, and then you collect information about what that segment wants, and that pulls back into your product roadmap. But we don't have engineering teams that are specifically, you're working on, finance, crypto, you're working on sensor data. In general, as a database and other data infrastructure, you're often a horizontal product, although you find adoption typically in some areas more than others.
Okay, I want to be mindful of the time. I have, maybe we will do one real question and then 1 minute fire run.
Sure.
Okay, so one real question is like, okay, you have won so many awards and then like the research honors and stuff. Like, okay, so how do you do research at a a university like Princeton? Like, and then also a lot of like the research is funded by, Sloan Foundation, Princeton, Cisco, Intel, Google. So like, how do you like apply these like scholarships, or like do they just be like, hey, we just donate to the organization such as Princeton, and then like, or how does it work in the academic world?
This is not a quick question. Let me try to answer this in 2 ways. How do I work on problems? And this ties back to the thing I talked about before. In the end, I never liked doing research by looking at last year's, in computer science, we publish in conferences. And what a lot of grad students do is they look at last year's conferences and they read the papers and they say, can I actually improve that result by a little bit?
Okay.
And that never excited me. And I even think when I was a researcher, I kind of like, as a sponge, like to read from lots of different, including like what's happening in startups, what's happening in industry, what's happening in markets. And you get a sense of shifts of behavior, that often introduces new problems. And that would often motivate the type of problems I work on, or at least that I was
Mm.
particularly excited about. They say a lot of in research, you can be first, you can be best, you can be last.
Mhm.
I often like to work on problems. I'm not saying we did this always, but I actually like to work on often be the first as opposed to the
Mhm.
best. It's just the type of problem that excited.
Mhm.
Um, so that's generally like when there's this taste of a problem selection, I like to think about, what problems we're solving as opposed to how do I improve a result? I know it seems
Mm.
like a minor thing, but a lot of research is how do we improve this result by 5%?
Mhm.
Uh, the funding situation is, grants. First of all, most funding in academia is primarily through government grants. I mean, yes, I raised some money from industry, but like 90+% is actually federally funded through the National Science Foundation or other things.
Mhm.
Typically, and even when it comes to industry, you as a researcher, the term is a PI, primary investigator, are
Mhm.
submitting grants yourself to these organizations. Yes, it flows through whatever university you have, but they are really
Mhm.
awarding it based on the grant proposal you are making. So they're not awards, and they're not monetary rewards to recognize past results.
Mhm.
They're more a proposal about future research that you will do.
Mm.
And that
What do you
primarily
like?
goes to fund graduate students. I mean,
Mm.
PhD students are funded, their salary and tuition is funded by grant money that's typically raised by their advisors.
What are some ideas in the research part that's just like completely cannot turn into a product slash like monetizable? Because I constantly hear about my friends go to like the Neurops,
Europe's, yeah, it's
Neurops, yeah,
it's a ML conference, yeah.
and then and then like obviously VCs goes too, but like I don't really know if like I mean, do we just like gave the best like presenter like a like money and then like just like ask them to start a company, or like how does this work to approach like the best scientists to like actually work on something commercialized?
Well, I think there's two things. One is I will say, um, I mean, in the end, uh, long term, if your goal is to build a business that has enterprise value, sells a product
Mhm,
or something that people buy, it's the totality of your offering that people are buying.
mhm,
And so that fits very much in their needs. And one of the big difference between academia and industry is academia, it's like the biggest value is the novelty of the technical result and the idea.
mhm,
And when it comes to a company, it's like, are you actually solving an important need I have?
mm,
And that need could be boring. It could be not be interesting, but it could be really important to them.
mhm,
And so that's one of the, I mean, can every research, most research problems like, you know, requiring, let's say, a company to completely re-platform their entire thing to
mhm,
save 10% is not going to be in any case worth it for them. That might be a fine research result, especially if it's using
mhm,
an interesting algorithm. So again, the taste of what's important and is just different. I think the biggest thing about going from academia to industry is that I think industry, especially when you're customer working, you actually have to have almost more humility.
mhm,
In academia, your job is to kind of tell the world why your idea is the best and
mhm,
people should follow you. And in as a founder in a startup, your job is to kind of to listen to the problem and the pain of users and see if
mhm,
you could solve for them. That's a very different mindset.
mhm,
And so when you start out as an academic, you come on the call and like, let me tell you why I built is the best thing you could ever do.
mhm,
And after you give them some assurance, it's like, what problems are you facing? Like,
mhm,
does this work? Does this work? Do you care about it? It's much more of a discovery thing. And so some people like to make this transition from academia to industry. For some people, it's maybe not the best fit.
mm. What are you drive by? Oh, okay, so we'll cut into fire on in 1 minute. So what do you drive your like, what's your, like, personal internal drive for this thing? Because it sounds like they're, like, very different.
I like
Uh,
solving people's problems.
okay. Fire on. What's your favorite book?
I don't even know anymore. I know that sounds sad. I haven't read a book in too books in too long.
Okay,
I
what's your
used to read a
favorite?
lot of science fiction and fantasy, although that's pretty
Oh,
boring.
okay. Wow. Are you like a Star Trek fan?
Never liked either of those particularly too much, actually.
Oh, wow, interesting. So who made the biggest impact in your career?
I think my probably my PhD advisor for I think teaching passion about the problem.
Mm,
Uh,
what does that mean?
I mean, he taught somebody to be kind of passionate about figuring out problems and solving them.
I don't I didn't know how that could be like kind of teached like by,
Well, I don't think
being
I think it's
curious
a by
about
osmosis.
something.
Like you see people who are excited by it, and it
Mhm.
kind of excites you, and it kind of
Got
pushes
it.
you.
Okay. So who would you invite to your dinner party?
Uh, I don't know.
What?
These are the questions I should prepare that I'm saying talking to
Where can we find you outside of work?
outside of work, outdoors. I like to hike and climb and do those things.
Wow, amazing. Well, Mike, thank you so much for coming on the show. Thank you for the master class for about like database for normies.
Thank you so much, Grace. It was really a pleasure.
Okay, let me quickly end stream.